Welcome back. Today we are diving into Cell Broadcast Service or CBS, a critical piece of India's emergency alert infrastructure that is being tested by C. Dot. Before we get into the technical details, let us start with the why. In an emergency, the difference between safety and harm is often measured in seconds, not minutes. That is the problem CBS is designed to solve. Getting the right alert to the right people quickly without depending on app downloads, network congestion, or manual coordination. CBS is not just another messaging tool. It is a nationwide public warning capability built by C. Dot as an indigenous platform. That means India is developing critical alerting infrastructure in-house rather than relying entirely on external systems. Think of it like a digital siren that can reach every compatible phone in a defined area almost instantly. Now let us define what CBS actually is. Cell Broadcast Service is a 3GPP defined teleservice, which means it is part of the mobile network standard itself. It lets authorized providers broadcast short messages to all mobile devices within a defined geographic area. And here is the key. It happens simultaneously, instantly, and without any acknowledgement from the device. Think of it like teletext on television. One signal goes out and everyone tuned in sees the same message at once. The difference is that CBS works at the mobile network level, so it can reach devices even when the user has not opted in or registered or enabled a special app. Let me emphasize what that means practically. No data plan required, no SIM registration, no opt-in needed. That's what makes CBS so valuable for emergency alerts. You do not have to wait for people to download an app or enable a service. The message just reaches them. CBS is formally defined in 3GPP Technical Specification 23.041 as Teleservice 23. Now let us look at how CBS behaves in practice. The big idea to emphasize first is why CBS is so effective. It is designed to push information out at scale without waiting for any response from the device. That one-way model is what makes it reliable for urgent public alerts because the network is not slowed down by acknowledgements or individual sessions. Let me break down the 4 key characteristics. First, one-way broadcast. Messages flow from the network to the device only. No acknowledgement comes back. And that's exactly what makes it massively scalable. The network does not have to wait for millions of devices to say I got it. It just sends. Second, geographic targeting. CBS is not a broadcast to everyone everywhere by default. It is precision targeted. The originator and the PLMN operator define the coverage area together. So the message can be limited to a single cell, expanded to a region, or extended across the full network depending on the situation. Think of it like a digital emergency siren that only sounds in the places that need it. Third, cyclic repetition. The reason CBS repeats messages cyclically is not redundancy for its own sake. It is there so people who are moving, entering a new cell, or momentarily out of coverage still have a chance to receive the alert. If you are driving through the area, the message does not rely on you being in the right place at the exact right second. That makes the system resilient rather than fragile. Fourth, mobile terminated only. CBS is not a conversation and not a user initiated message flow. The content originates in the cell broadcast center and travels outward to devices. It does not come from the handset and it does not require a two-way session. CBS is purpose built for high reach, low friction, one to many communication, and every design choice supports that goal. Now let us talk about the shape of the message itself. CBS is designed to be compact, repeatable, and dependable because in a broadcast system, the format has to work at scale. A single CBS page is 82 octets and it uses the default GSM character set. If you want to support other languages or symbol sets, that's where alternative data coding schemes come in. The message payload is intentionally constrained. The format is built for efficiency, not for long form content. But here is where it gets smart. You can concatenate up to 15 pages together. So while a single page is small, you can chain them to create longer messages when you need to. And the whole thing gets wrapped with a message identifier and serial number, which brings us to the next critical piece: message identity and deduplication. Once a message is on the air, devices need a clean way to tell whether they are hearing a fresh alert or the same one again. That is exactly what the message identifier and serial number do together. They act like a unique stamp on the broadcast, so the device can recognize duplicates and silently suppress them. Here is the operational benefit. Deduplication is handled in firmware. App developers do not need to build any special logic for it. That is the strong point because it shows how the standard reduces complexity all the way down to the handset. Next, DRX mode, discontinuous reception. There is a tension in mobile networks. Devices need to stay reachable, but they also need to preserve battery life. DRX solves that. The phone can sleep between broadcast windows and still catch the message when it matters. You can compare it to checking a mailbox at scheduled times instead of standing outside it all day. To summarize, CBS messages are small, uniquely identifiable, and battery friendly, which is exactly what a large scale emergency broadcast system needs. Now that we have seen what CBS is, the next question is who actually sends the message. That matters because the power of CBS is not just that it can reach a lot of people quickly. It is that it does so through a controlled, authorized path. Think of it like an emergency alert system with a very clear chain of command. At the edge of the system, you have the cell broadcast entity or CBE. This is the source of the message. It might be a government emergency office, a traffic control center, or a weather service. The CBE is not the network itself, it is the organization that has the authority and the need to issue the alert. From there, the message moves into Cell Broadcast Center or CBC. This is the coordination hub and it is really the heart of the architecture. You can describe it as the system's dispatcher. It takes in messages from one or more CBEs, decides where they should go, and ensures they are delivered to the correct cells at the correct time. That centralization is important because it prevents chaos. Multiple sources can publish through one managed channel instead of trying to reach users directly. Then the CBC passes the message down to the individual cells or base stations, and those cells broadcast it to every device in coverage. That is the final step, and it is what makes CBS so effective. No registration, no phone numbers, no one by one delivery. If you are in the area, you receive it. Here is the simple flow. CBE creates the message, CBS coordinates it, and the cell broadcasts it. It is a lot like a newsroom. The reporter gathers the information, the editor decides how and where it gets published, and then the printing press distributes it to everyone in the region. Not every broadcast needs the same urgency, and that matters because CBS is trying to balance speed, reach, and network efficiency. The system is not just sending messages, it is making smart decisions about when to repeat, who should receive, and how to stay useful without overwhelming the channel. As an example, the dynamic information. Considering traffic updates, flash floods, and earthquake alerts can become outdated in minutes, so they need to be repeated frequently. Here is why. If a car keeps moving, a driver might pass out of one cell's coverage before seeing a message once. Repetition is what gives the alert a real chance to land. Frequency is not about being noisy, it is about making sure time sensitive information actually reaches people before the moment passes. Next comes static related information such as weather forecasts, general advisories, or broad public messages do not require the same urgency, so they can be broadcast less often. That reduces channel load and frees capacity for truly urgent alerts. The network is always asking, how often do we need to repeat this for it to be effective without wasting airtime? Each message carries metadata through the data coding scheme, including a message class and language code. That means users are not forced to treat every broadcast the same way. They can filter out content they don't want. For example, messages in a language they do not understand or categories they consider irrelevant. Think of it like a mailbox with sorting rules. The system still delivers widely, but the receiver can decide what gets attention. This is not just a convenience feature, it is what keeps broadcast messaging practical across diverse audiences. Next comes network control. In some regulatory environments, networks can remotely activate CBS reception on compatible devices. This is especially important in national emergency systems like India's disaster alert system, where waiting for users to opt in would be too slow or unreliable. Authorities can create immediate reach to every compatible phone inside an affected zone. In an emergency that turns the device from a passive handset into an active public warning endpoint. Smart broadcasting works because it combines urgency, efficiency, and control. High frequency repetition handles fast changing threads. Low frequency repetition avoids unnecessary load. Filtering keeps messages relevant, and remote activation ensures critical alerts can still reach everyone when it matters most. We have now laid the groundwork, what CBS is, how a broadcast message is built, and how it moves through the network. That's the what and the basic how. And it is important because without that foundation, the deeper architecture can feel abstract. In our next videos, we are moving from concepts to the actual system design. First, we will look at CBS architecture. The big idea is why the architecture matters. CBS is only useful if the network can reliably reach lots of devices at once across different generations of mobile technology. We will connect the roles of the CBC, CBE, and radio access network to 2G GSM, 3G UMTS, 4G LTE, and 5G. So you will understand this is not a legacy feature, it evolves with the network. Then we will move into CBS protocols. Here the goal is to help you understand the mechanics behind the architecture, how the message actually travels, which interfaces carry it, and why commands like SBC, write, replace, and kill matter. These protocols are what makes CBS operational rather than just theoretical. Architecture tells us who does what, while protocols tells us how they coordinate. Now that we understand the building blocks, the next step is to see how they talk to each other. CBS is a layered system and each layer exists for a reason: scale, control, and reliability in emergency broadcasting. Thanks for watching. Subscribe for the next deep dive into CBS architecture.